Alright guys, on the left hand side is my original Pathfind code in Freepascal, and on the right hand side in this Robot Revenge on Raylib window, that's the updated code that allows me to use the pathfinding code with Raylib. And I've added a few enhancements to make it work, and I'll go through that afterwards. But the eventual code will not display the yellow line or the path. I'm just showing it in this example to show how well it works. So as the player moves around, that's the green box. We keep updating the path code uh, so I can find the player. So it recreates everything in the path code. So on the left hand side, you see all those different arrows. Well, on the right hand side, we're doing the same thing, but you're not seeing all the pathfind arrows or breadcrumbs, as other examples would call them. So we're able to trace the location of where the player is uh, by using these breadcrumbs or path path arrows. So I've explained this in a previous video. You can check that out. But ultimately, in this robot game that I'll be working on, the player will be able to collect some kind of object, and the robot will be trying to chase him down somehow, firing lasers. Um, and I think that's as far as I'll go with the demo. But I thought it was cool just by the way it's able to find a path with the different locations that go on the screen. That I would release this part of the code also. It might help somebody figure out some some of the problems they might be having trying to integrate the original code I wrote into a game. So this will give you a bigger hint. So now I'm going to flip to the code and show you what I've modified basically. So let me start from the top here. So I've defined a bunch of constants here. This is the size of the Raylib window. You could adjust that, but it's kind of hard coded in that everything works correctly with these dimensions. Um, Now, if you've seen the previous breakout demo, you'll notice a lot of things are similar, and it's because I just took that code and modified it. So some things we don't even need at this point, I have those commented out. I should just delete them. It's a lot easier to understand that way. But so I have some code that gets initiated, and it's to draw the robot. In this case, we're just drawing a red dot, and to draw the wall, we're using beige color, and the player is green right here. And we can change these at any time. And let's change the player to blue. Run the demo again. And now it's blue. It's that easy to change. And like I've indicated before, instead of drawing a shape, we could comment this out and actually draw a sprite, and it would function just the same. But for now, I'm just keeping it simple. The walls here, we can change this to line, and instead of drawing a solid wall, we uh, set lines. Let's see if that works. Yeah. So instead of drawing a solid box, it draws just the outer parts. Let's change that back. Now it's popping the Raylib window on my second monitor. That's why I keep constantly moving it over. And okay. And we have some collisions here that we're checking for. So each time the player is moved, which is the green box, um, it, it it's possible that it moves into an area of the walls, and we're checking which direction it came from, and then moving it the opposite direction 4 pixels, and that keeps it from getting stuck inside a wall. And I'll show you where we're adding that in. Okay, so the player is shape 1, and so we're checking with collisions for all the different walls. So we got 7, 8, 9, 10, 11, 12, and at any point if the player touches one of those walls, we call this routine, which is right here. All right. So just like the breakout example I did, we initiate the shapes, the collisions, and then we set the values for all the different. Right here I have the walls that are on the top, bottom, right, and left. We're not doing any collision checking on those. We're just using the set shape to draw the wall. So that's all it's doing here. It's not really checking for collisions because we haven't defined any with these walls. So bottom wall is shape ID 3. We're not adding any collisions here, so we're never checking, but these this border here, those are the walls. So this is top, left, right, and bottom. And I think it just makes it look a little better. All right, let's move that to the side again. And in the previous example, also had a flashing text option. I left that in because I think that looks kind of cool. So the flashing coordinates here. So I'm taking the location of where the player sprite is or shape and converting it to a grid coordinate. And that's where I'm feeding it to the path find routine. So let me just get back to this. So I'm also using to display the flashing text a timer routine. So I'm setting this right here to be called every zero point 0.2 milliseconds or microseconds. I haven't figured that out yet. I should probably look into it. But it's flashing, it's calling the flash text routine here that often, and we're just changing the flag whether to flash the text or not. And then when we're displaying the text, we're checking if that flag is set, and if it's set, we display the text. Right here, this is just some coordinates that are in Pascal strings. Because Raylib is a C-based library, we have to convert that to null terminated strings. So the easiest way I find to do is have all my strings in regular Pascal string and then just typecast them and turn them into C-style strings. So by doing the typecasting over, it's turning them into null terminated strings. So you don't have to get really fancy, just do everything the way you normally do. And when it comes time to display, just cast them. That's what I've been doing. And One thing I did change from the breakout example is the way I handle keys. Before, these were all separate if statements. I changed them to if, else if. That'll prevent going diagonally, hitting two keys at once. And when this happens, it creates problems with my player. He ends up going inside the walls more often, and by doing else ifs, we're preventing that. And you could also flip to full screen in if you're running this. I'm not going to do it because my screen capture doesn't display it properly. But if you're running this on your own computer, hit the F key. That'll toggle into full screen and you get a better idea how everything looks. Um, so this is the main routine here. We're we're drawing everything. So we're clearing the screen using black color. We're drawing the shapes, and then we're drawing the path, and we're displaying the text. And we could easily change this to another color. Let's go for blue. And now it looks like this. But my player is also blue, so I forgot to change that back to green. So it should look better now. Okay. So this might be a better color to have a background blue color. Yeah, it works just the same. And let me find okay, so the code here to draw the path is I'm storing the path in this object. It's a global object that I have at the beginning of the program here. So SQ simple Q, and we're constantly updating that. So this gets called update player on grid, and we clear the grid except the walls, and we map wherever the player is and wherever the robot is to the grid as well. And then we call this routine create path grid start, and then we call this routine to find the path and store it in the queue in here. And once everything is stored in here, we can draw it with the draw path that where is it? Here we go. So it's right here. So we go through all the entries. So we get the count, and then we get a record. The QREC is just the XY coordinate with also another value. I'll go through that. I'm going to flip to the pathfind code, and I've explained this in the pathfind video. You can watch that. The thing I have changed, instead of just having a byte here to store the direction, I've added also a C value, um, and that's just a counter value, and that helps determining which look which let me try to which direction we start moving from where the robot is to find the player. And the smaller the value, the better path. So if let me bring up So internally, the grid has all these arrows. So let's say this guy here is the one we're trying to find. Um, well, let's just choose this one because we can see the arrows. So if we were starting from this location, we could take several paths. We could take this path on the right, this path below, or this path above. So, and we would just follow the arrows or the breadcrumbs in reverse order. So this arrow is pointing down, we would go the reverse way. Again, down, we would go up, down, up, down, up. And here the arrows are pointing to the left. You can't, sorry, to the right. You can't see them, but again, we would go and we would end up following the same path here. But in order to decide which direction do we need to go, each of these direction arrows also has a C value now. And we check around to find out which is the smallest C value. So that means it's the shortest path or the path that we found first. So each time we determine the path, we check to the right, we check to the left, we check above, and we check below to find out which is the best direction. And then we start finding the breadcrumbs or the arrows, and that creates our path. And so a lot of this code is in here now, and I wasn't quite sure how fast this would work, but basically it works fast enough that I could actually create a game on this. I thought it might be going too slow at some point, but I've modified a few of my settings, and it looks like it will be fast enough to do a simple game. As you get more advanced, it might not be fast enough. I still not quite sure. But while doing this, I also discovered that this same code can probably be used in a maze game. Um, so these blocks don't look like a complicated maze, but in fact, they're a simple maze built up of just bigger blocks. We can make it more complicated by making the blocks smaller, and that creates a maze basically. And theoretically, the same code that works here, we should be able to create some kind of maze and use the pathfinding code to find, whether the maze is solvable or create a path from let's say this was the beginning of the maze and this was the end, it would find the correct path to get out. Um, so that's one thing I'm going to put on my to-do list to try this in the future if I can randomly generate mazes and solve them. And that could also be another game that this code uh, be modified to work with. Um, so I'm going to put this code on GitHub as well. It's not a complete game, um, but I think just the being able to view how the path is created dynamically, I think that would help somebody, incorporate this code into some kind of game. So I'm going to end it here and look for the link in the video description, and it should be on GitHub right after I post the video.